All right, somebody said they needed help on 43. Here was 43. Your job was to factor this. 6a squared minus 13a minus 15. The tricky thing about this problem is the beginning and the end has more than one choice. Like 6a squared could possibly be 6 and 1, 6a and 1a, or 3a and 2a. 15 could be 1 and 15, or 3 and 5. I normally start guessing with the ones that are close to each other. So when I tried this one, I started with 3 and 2. And I don't think that's the winner here. But sometimes you just got to keep trying until you find the right combination. Oops, that's a 2. All right, so I started with 3a and 2a and 3 and 5. I put the 3 here and the 5 here. That gave me a 6a and a 15a. I'm trying to get to 13 in the middle, negative 13 in the middle. That's not going to work. But I switched the positions before I gave up on that guess. So let me try the 5 here and the 3 here. That would give me a 10a and a 6a. Again, that's not going to add up to 13 or subtract up to 13. Before I gave up on my 3 and 2, though, I also tried 1 and 15. So I know that 3 and 2 doesn't work with the 3 and 5. But now I'm going to try 3 and 2 with the 1 and 15, and I don't think that's going to work either. That's going to give me a 2a and a... Ooh, maybe that does work. A 2a and a 15a. Oh, whoopsie. I'm sorry. That would be a 45a. Yeah, that's not going to work. And even if I switched it, I would get a 30 and a 3. So this is about where I went, oh, I bet it's not 3 and 2. Well, same thing. 3 and 2, 2 and 3. So then I went back to 6a and 1a and started all over. I'm going to go back to trying, this one didn't work. So I'm going to try this one with 3 and 5. Let me try the 3 here and the 5 here. That would give me a 3 and a 30. Nope, not going to work. Switch positions, though. Put a 3 and a 5. Hopefully this will finally give me what I need, a 5a and a 18a. Yes, that can subtract to a 13. And I need a negative 13, so this needs to be negative. The 18 does, which came from this number right here and the 6a. Finally. So it's sometimes the guessing and checking can be tedious. Sometimes you get lucky on the first guess. But this is the only combination that would work. All right, anything else? Number which one? 13. 13 was 4x squared minus x minus 5. And again, the guessing really comes on the front end on this one, because 4 could be 4 and 1 or 2 and 2. 5 could only be 5 and 1. So this one shouldn't have as much guessing and checking. What do you want to start with for the 4x squared? 2x and 2x or 4x and 1x? That's probably how I would have started as well, but I don't think it's the winner for this. Let's try a 1 and a 5. That's going to give me a 2x and a 10x. But I'm trying to subtract up to a negative 1 in the middle. So that's not going to work. And guess what? If I switch the positions, it's not going to change anything either. Because if I put a 5 here and a 1 here, it's still getting multiplied by 2 on each end. So what does that tell me? 2 and 2 didn't work for the 4x squared. I've got to adjust my guess. So I'm going to go back and try 4x and 1x. And 5 could be 5 and 1. I really don't want to put the 5 here because what's that going to make? That's going to make a 20. So again, I'm going to try to kind of do some educated guessing here. If I put the 5 here and the 1 here, look what happens. I get a 5x from my insides and a 4x from my outsides. And sure enough, if the signs are different, that can make a negative 1. But I need the bigger one to be negative, which is this one right here. And I need the smaller one to be positive, which would be that one right there. And that gives me everything I need. 4x squared. Then I get a negative 5x, a positive 4x. Makes a negative x in the middle. And I sure do get negative 5 on the end. So that's the winner. Okay, there is a different method that I have a... Folks, listen up. Guys, if you don't like the guessing and checking, there is a different method. And I will have that on Schoology. I'll title it Different Method if you are one that hates guessing and checking. I promise you, I think it's easier. But if you want to check that video out, you're welcome to. All right, pass up your homework. Let's get out our notes. Today we are factoring what's called the difference of two squares. This is very easy. The hardest part about this is recognizing it when you see it like a week or two from now or way in the future in May. Kids forget how to do this, even though it's very simple. Okay, what you're doing is you're going to factor the difference of two squares into two binomials. Our directions here are to factor into two binomials. Now, normally we had problems that looked like this. We were taking a trinomial and factoring into it its two binomial factors. That's what we've been doing for 2 or 3 days now. That's what you did for homework last night. You had a x squared term, an x term in the middle, and a constant at the end. Well, today, look what your problems will look like. I promise you it's easy. Don't groan. X squared minus 36. That's a binomial. Let me just tell you, it's not normal to factor a binomial into two binomials. That's not a normal request. The only reason why this works is because it's a special case. It's a special case called the difference of two squares. And in fact, it really is a trinomial. It really is, except I guess it's technically a binomial, but we can write it as a trinomial. Look at the format of a trinomial. What's x squared minus 36 missing? The x. It's missing the middle term. Guess what happened to it? It canceled itself out. It canceled itself out. In other words, there were, once I added them up, no x's. 0 x's. Are you with me, Zoe? So if I told you I'm going to force you to write this as a trinomial, you could, but how many x's would you put in the middle? 0. 0 of them. So it could be written as a trinomial. It's just if there's no x's, we just don't write the x term at all. Now let's think about how the middle term would cancel out. 36 has lots of possibilities. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. What pair do you think could cancel each other out? 6 and 6. So it kind of eliminates the guessing and checking. How is 6 related to 36? It's the square root of 36. Because 36 is a perfect square. And guess what? X squared is a perfect square as well. And they are being subtracted. This is the difference of two perfect squares. So look how easy this is to factor. I want you to understand, though, the reason why this is so easy to factor is because the middle terms canceled out. And the only way a middle term is going to cancel out is if you have the same factors, but one is a positive and one is a negative. And if your last term is negative, your signs are going to have to be different anyway. So look how easy this guy is to factor. What's the square root of x squared? X. What's the square root of 36? 6. Make one a plus and one a minus. That's how you factor difference of two squares. Now, if I were to multiply this back, remember this binomial got factored into two binomials. That's not normal. Normally it's a trinomial. The only reason why that works is because it's a special case called the difference of two squares. Only perfect squares works on this. X plus 8. Yes. Okay, now let's check this. X times x is x squared. And watch what happens to the middle term. I get a plus 6x, and then I get a minus 6x, and at the end I get a negative 36. And what happens to these guys? They cancel out. It could be plus, minus, minus, plus. One has to be a plus, one has to be a minus. It doesn't matter which one. All right, number 2. Let's try another one. Number 2. X squared minus 64. This is the one, Ariana, you just mentioned. First of all, this only works if it's perfect squares, and it only works if they are being subtracted. Are they being subtracted? Are they perfect squares? What happened to the middle? It canceled out. So I really don't even have to go through that process of figuring out all the factors of 64. What does it have to be? 8 and 8. Why does it have to be 8 and 8? Because those are the only ones that are going to cancel each other out. Nothing else would work. So you don't even have to do all that business. You just take the square root, make one a plus and one a minus. So this would be x plus 8, x minus 8. It doesn't matter which one's a plus and which one's a minus. You could put the minus first, you could put the plus second. But look at what I get sometimes, especially when we haven't done this. Like tonight when you do this homework, you're going to get in a groove and it's just going to be super easy. It's 2 and 3 weeks from now when you haven't seen it in a while. And this is in the middle of a bunch of other kind of factoring. I want you to think about the fact that the middle is gone, and the middle can only get gone if the factors are exact opposites. One's a plus and one is a minus. This is the weird stuff I see after we haven't done this for a while. And kids will tell me, well, I get a negative 64 on the end. I get an x squared on the beginning. That's correct, but will this middle term cancel out? No. This would give me x squared plus 32x minus 2x, and I do get a minus 64 on the end, but do these cancel out? No. So again, there's no guessing and checking. It's the square root of that guy. And the square root of that guy. All right, how can it be more complicated? Really, it can't get much more complicated. 16x squared minus 49. How about if we put a number on the front and the back? Are those perfect squares? Absolutely. Yeah, 16 is a perfect square. X squared is a perfect square. 49 is a perfect square.
So it's 4x and then minus
4x plus 7. 4x minus 7. Pretty much. And if you multiplied it back, you get 16x squared minus 28x plus 28x, which again, those guys cancel out, and then negative 49 on the end. Part of your homework, yes. All right, how about this one? 196x squared minus 121. Here is where it could get a little tricky, I guess, if you don't have the first 15 perfect squares memorized. Now, we put these in your notes a while back. 121 is 11, but 196 comes up quite a bit as well. It's a perfect square. It's not 13. You're close, though. It's 14. So what would this factor into then? 14x plus 11, 14x minus 11. If they are perfect squares and they're being subtracted, all you got to do is take the square root of each one, put a plus and put a minus in between them, and that's going to be your answer. Okay, now how could we make it a little more complicated? How about this? Put it backwards. Let's see, 64 minus x squared. If it's backwards, just leave your answer backwards. Don't try to switch it around, guys. That's going to make it more complicated. Are these perfect squares? Yes. Is it written backwards? Sure, but that's okay. What's negative in this problem? The x squared. So just keep them in the same position they are in the problem. The square root of the first one should go here, which is what? 8. What's the square root of x squared? X. And one is a plus and one's a minus. So if it's backwards, just leave it backwards. If it were the other way, it just gets more complicated when your lead term is negative. We will practice some of those, but just not today. Let's just focus on learning it this way. But there's not going to be that many backwards ones. Now, here's another thing that they might throw in there to try to confuse you. X squared plus 16. Okay, somebody said x plus 4, x plus 4. Right, so if you're asked to factor this into two binomials, it's not possible. Correct. The special case that works is when it's the difference of two squares. This is not the difference of two squares. This is the sum of two squares, and it's not possible to factor it into two binomials. That's not possible. Somebody said, sure it is. You just do x plus 4, x plus 4. I'm not talking about you. Last period. Last period. What's wrong with this? You'd get a middle term. The middle term wouldn't cancel here. The middle term's only going to cancel if the signs are opposite. You'd get x squared plus 4x plus 4x plus 16. You get the front and the back, but you also get a middle term that you didn't have. And if you make the signs both negative, you're also going to get a middle term. And if you make the signs different, you're not going to have a plus 16. You're going to have a minus 16. So it's just not possible. No, not really. There's no special symbol. You would just write not factorable, not possible. Or this, x squared minus 10. If you were asked to factor that into two binomials, why is it not possible? Yeah, because it's not a perfect square. Doesn't mean that we can't find solutions and things with a calculator, but to factor it into two binomials, that's not possible. Because this is not a perfect square. The only way that you can take a binomial and factor it into two other binomials is when it's the difference of two squares. That's a very special case. And the hardest thing is recognizing it when you see it. Now, we did put the first 25 perfect squares in our notes. I don't really have time for you to rewrite this whole thing if you want to take a picture of it with your camera or watch it on the video later. But here are the first 25 perfect squares. You really should be familiar with these, especially up to 15 times 15. And another one that comes up a lot is this one right here, the 25 squared. So either watch the video and freeze this screen or take a picture real quick. Most of this we put in our notes. We skipped a few, but most of these should be in your notes. Okay, you really don't have time to copy them. You do need your own paper for the daily grade, so you might as well get that out. Okay, I also want you to write down the homework. Here's the homework. Now, the homework, yes, difference of two squares. You're going to get into a groove, and that should take you maybe 5 minutes, especially if you have this list to refer to. I also want you to go back and pick up just 5 problems from yesterday, because this is the most frequent type of factoring you're going to be responsible for. So, your homework is 2 parts here, 2 different pages. Write that down. I'm going to leave this screen up here because I put the formulas for area and circumference of a circle and area of a triangle. That's what's going to be on your daily grade. So I'll leave this up here. You need your own paper for the daily grade.